Hello everyone, I'm Neeraj, part of Capro open source platform working as a cloud infrastructure lead. Today we are going to discuss about Amazon DynamoDB. So let's start. The course outline would be we are going to discuss introduction of Amazon DynamoDB, core component of DynamoDB, indexes in DynamoDB, read-write consistency and lab on it. So DynamoDB. Okay. When we discuss about any database, you will have an idea in your mind that who will take care of administrative work as a DBA. So it has some structure, for what purpose it has to use, is this as a relational or non-relational, how much scalable it is, all this point come in your mind. So first thing about the DynamoDB, in a general layman language, it says it is a database where no DB is required. So this database is much for the developer loving database where a DBA work is very nullified. Everything will be managed by AWS in backend. You have to just create table, insert your records, you do your whatever things you want to do. I will show you in the lab. A normal developer can learn it and he can write his code according to the DynamoDB table, only how to link to the DynamoDB username, password, or whatever this access restriction, all this small part he can easily learn. He doesn't have to manage this maintenance kind of like what we do in Oracle, SQL Server, MySQL, RDBMS. No, even for the MongoDB we have to maintain a lot. Here we don't have to do. So first, an important part, a DynamoDB is a no DBA database, or you can also say a DynamoDB is a serverless database. That's the reason all the code loving people who draw their solution architect, who draw their serverless architecture, they choose DynamoDB. Because in DynamoDB you only know there is a table, you are loading data, unloading data, you don't know which server it is, which side it is storing, what kind of partition is happening. You are not much bothered about that. Third important point is it's a NoSql database. It work on a key value. Fourth important point is, as it is a NoSql database, it is dynamic in terms of their column values. Like suppose I'm just giving in a layman language, one row has a 3 column, so second row can have a 5 columns. So dynamic schemaless or dynamic you can say. So let's see this one by one. Fast and flexible, fully managed NoSql database service. It's a database and as a service product of Amazon cloud. It is stored data in a key value pair. Just you have to define what is the column value, column name, and its value. Data is stored on SSD. So we don't know where it is going to store. But AWS says when you choose Amazon DynamoDB, we will store data in SSD volume or SSD storage. Data is spread across 3 geographically distinct data center, means 3 geographically availability zone. This means that whenever you store a table, it has a 3 replication copy in 3 different geographical location within a region. So how I have to maintain? We don't have to maintain or we have to say that replication factor this 1 2 3, no, nothing. These are the informative things what AWS says we are putting here. Expensive for the write but extremely cheaper for the read. That comes to with the read capacity unit and the write capacity unit. We will discuss in detail in a subsequent class videos. Event driven program, yes, like if something happened on a database, a developer again write the code to create an event. We'll see that what is exact meaning of event driven program. Serverless concept. You will never know which operating system it is installed and what is the OS. You will never know. Even in RDS, at least you will come to know which database and which operating system it has been installed, but here you will never know which server it is installed. It is suitable for all the applications that need consistent. Which kind of application it is suitable? So it is suitable for all the applications that need consistent single digit millisecond latency at any scale. It's a hyperscale database for modern app which need performance at any scale. It's a scalable. Scalable means like, I mean, we'll discuss about the component, so we'll discuss it. Great fit for mobile, wave, and the gaming application, and technology, IoT, and many other applications. So these are the main point of DynamoDB. It is, if you use a partition key, we'll see that if you use a partition key and a short key, then use two attributes together to uniquely identify an item. It's very simple to create a primary key with on a single column, or a composite primary key more than one column. So because see, the most of case the NoSql architecture depend upon how the application is querying the record. It's not how your data is getting loaded. In RDBMS model, you model the diagram or the table and layout would be depend upon how you are loading the data. But here in NoSql database, the data model mostly depend upon how the application is querying the record, not how to. Now, so we'll go to the next level. DynamoDB core component. So every DB has a core component. So what are the core component in a DynamoDB? Table, item, and attributes. A table is a collection of items and each item is a collection of attribute. So the table, item, attribute, table is a collection of items and each item is a collection of attributes. Don't be confused with the terminology. I will say it. Table means very similar to the table in RDBMS environment. Item here is a row and attribute here is a column. So table, row, and column. So here in DynamoDB we say item and we say attribute for the column name. It's very simple. So with the DynamoDB you can create database table. In DynamoDB you don't have to create any database, you don't have to create any container, nothing. You just have to create a table. That's all. So with DynamoDB you can create a database tables that can store and retrieve any amount of data, serve any level of request traffic. Yes. And the number of item, that is called number of row, doesn't restrict with a limit with a table. No. It's nothing like that, only 5 million, 10 million, 20 million. Yeah, if they go higher, there is a repercussion and there is a effect. But as documented, there is no limit for the number of item in a table. You can scale up and scale down your table throughput capacity without downtime or performance degradation, and use the AWS Management Console to monitor resource utilization and performance metrics. So we'll discuss, I told you there is called throughput capacity, read write capacity, and there is a provisional capacity and on-demand capacity. These all are capacity things we'll discuss in our future videos, but here just understand like we can increase the table throughput capacity online without disturbing the current setup. DynamoDB allow you to delete expired item from the table automatically to help you reduce the storage use and cost of the storing data that is no longer relevant. That is TTL, time to leave. It's a very simple concept you might have learned in MongoDB, Cassandra. Now indexes in MongoDB. So if there is a database, there is an index. Can we use index in MongoDB? Yes, First is a primary key. So when indexes in a primary key, it's very similar in the concept of creating a table in Cassandra also. If somebody knows Cassandra, if you want to create a table, you have to define a primary key. If you don't define a primary key or a partition key, you can't create a table. Very similar here in a DynamoDB. You can't create a table without defining a primary key or a partition key. That is also known as a partition key of an item or a hash attribute. Only data type that allow for a primary key attribute are string, number and binary. That line is very much important. Like if you want a particular column to be your primary key, the data type should be either string, number or binary, nothing else. Sorry. You cannot create any table in DynamoDB without defining the primary key attribute. I have already informed you. You can't do it. Now what is secondary index? So here the secondary index is a normal index apart from your primary key. The secondary index let you query. Suppose for it's very simple to the RDBMS concept, putting in where clause on the column, and so you can create index on the column, so it will query, you will be faster. Same concept here. Secondary index lets you query the data in the table using the alternative key in addition to query against the primary key. So if you want to do a search with the filtering on a primary key, that is possible. But what if you want to query a table putting a filter, there is a filter to put it the value for the other column or attribute, because in DynamoDB the word is used attribute. So on that attribute also you can create an index, and that could be a secondary index, and that behave as a normal index. So what is, again, after you create a secondary index on a table, you can read the data from the index in much same way as you do from the table, as you know that. So DynamoDB support two kind of indexes. First is a global secondary index, an index with a partition key and a short key that can be different from those on the table. So suppose you want to create a composite secondary key, very simple, either, or a simple key. So you can create indexes on any other column or attribute which is not the part of either a primary key or the short key. We'll see about what is the short key. Then what will happen in that condition? That is called as a global indexes or global secondary indexes. And local secondary index is, you want to create a secondary index and you have chosen one of the column or on the same column as a primary key or a short key. So that is called local secondary indexes. Same partition key but a different short key. Now, each table in a DynamoDB has a limit of 20 global secondary indexes by default limit and 5 local secondary indexes per table. You can increase the indexes, but you have to raise a service request with AWS support. This is, I don't know what would be the maximum after the service request, but here the current limit is 20 for global secondary indexes and 5 local secondary indexes per table. It's not per region or something or account. Now, partition and data distribution, just an informative purpose. So Amazon DynamoDB store data in a partition. The partition is a collection of storage for the table. Data stored in SSD drive automatically replicates across multiple availability zone within the region. Now the partition management is handled entirely by DynamoDB. You never have to manage partition yourself. I told you this is the DBA-less database. No DBA is required here. Partition management occur automatically in background. It is transparent to your application. Your application will not get affected. Your table remain available throughout and fully supports your provision throughput requirement. Global secondary indexes in DynamoDB are also composed of partition. Means whenever you create a DynamoDB, that will not DynamoDB. Whenever you create a global secondary indexes, like when you create indexes in RDBMS, what will happen? It create another segment. I I will, whoever know the DBA or DBMS part, I'm just comparing. Like whenever we create indexes on a column, it create the index for that column, it will create a separate segment, or you can say storage, where initial segment is allowed, storage is allowed. Similarly, when you create a global secondary indexes, it will create a separate partition, separate storage and separate partition, you can say separate segment, and that is composed of partition. The data in the global secondary index is stored separately from the data in its base table. Similar, like whenever you create an index on any RDBMS table, that whole column will be stored separately again apart from your base table, and index will be available as a separate segment. So whenever do the insert update, the column which is the part of index, the insert update also happen on the index segment. So it's very similar. This last 2 points is very much similar to the RDBMS index behavior, but the index partition behave in same way as a table partition. Now this is the information about the partition and distribution. DynamoDB stream, that is one of the optional component which can be enabled to catch any changes in your database, and that can create an event. An event can be invoked through the AWS Lambda. Someone if know this, invoke through AWS Lambda, and it can trigger to you can again ask Lambda to trigger any of the application function if you want to send some notification or some email. So let's discuss what is that DynamoDB stream. So the DynamoDB stream is an optional feature that captures data modification event in your DynamoDB. If you enable the stream on a table, the DynamoDB stream write a stream of record whenever one of the following event occur. So what are the event it writes? When a new item is added to the table, so the entire image will be, when an item is updated, the before and after image. I'm just shorting out. I've written whole the statement. An item is deleted from the table, then before image will be captured. Obvious, when item is deleted is a before image. If the item is updated, before and after image, and if the item is added, only the after image will be captured, including all the attributes. So these are the event for which stream can be enabled on the table. Now each stream record also contain name of the table, event timestamp, and other metadata. That information will be also available apart from the list of attribute. The stream record have a lifetime of 24 hours. After that, they are automatically removed from the stream. A stream will keep the event temporary. After that, if you want to put keep any action on the stream record, you processed it. It's a kind of queuing. It will be available for the queuing for 24 hours. After that, it will get cleaned. Now, DynamoDB stream enable powerful solutions such as data replication within and across AWS region, materialized view of data in DynamoDB tables, data analysis using Kinesis materialized view. All this we'll see as a use case in future videos. Now, very simple example is, suppose you have a table. I'll just give you an example. And in the table, you are getting you have a customer table. So a new customer is getting added, the new record will get added in the customer table. When the new record is getting added, and the DB stream will capture the new record, and it will send to the DynamoDB stream. Once the new record will get captured in the DynamoDB stream, it can invoke the Lambda function to write a trigger and send a notification to the new customer, welcome to a sign up, like we get a mail. Am I right? So that kind of use case we can use this DynamoDB and DynamoDB stream. See, suppose you have a customer table, you have 1, 2, 3, 4, 5 record. When the 6th record as a new customer got inserted in the table. So what will happen? The stream record will get written to the stream, DynamoDB stream, and then we can write a trigger on the table. It can invoke the Lambda, and the Lambda function can invoke simple email service and email attribute. It will take the value from the new record and it will send a mail to the customer. Like sometimes we do the sign up, after sign up we immediately get an email, thank you for logging to our server, we'll evaluate this and all, or welcome message. Like when do the sign up, we'll receive a welcome message. So kind of message we can send it. So this is the a simple use case of DynamoDB stream in a DynamoDB. Now the next is accessing the database. If you have a database, how to access? It's a very simple question. Tools for accessing database. In most cases, you write application code. I told you it's a developer database, not a DBA database. So you can use AWS Management Console, yes, or command line to send ad hoc requests to DynamoDB and view the result. Connecting to a database, DynamoDB is a web service, so interaction are stateless. Interaction with a DynamoDB always occur using HTTPS request and response. How to authorize if I want to get access? So in DynamoDB, authorization is handled by AWS Identity and Access Management. Request response. So the application send HTTPS request to the DynamoDB and the DynamoDB return an HTTPS response containing the result of operations. So how to access, how to connect, what are the authorization and request response, all we have discussed here. Now consistency. So what do you mean by consistency? When your application write the data to DynamoDB and receive HTTP 200K response, means write has occurred and it is durable. The data is eventually consistent across all the storage location, usually within the second or less. Why there is a consistency? Because backend it's a three-way replication, 3 different geographical location data will be replicated. So in that situation, we don't know which ability zone it will go and fetch the record. So there are read consistency and that called as a eventual consistency and a strongly consistency. Eventually consistency, very simple, like maybe your data has not written, still data can come, because if someone is loading a huge record and in between you are fetching the record, some of the record may be still, because it is a 3-way it has to write, then the write will be complete. Strongly consistent means unless and until the data will be completely, preference of write over the read. So once the write will complete, then the read will start. That comes as a strongly consistent. So the strongly consistent read are not supported on global secondary index. That is one limit. DynamoDB use eventual consistency read unless you specify, means by default the read consistency is eventual consistency. Read operations such as get item, query and scan provide a consistent read parameter. If you set this parameter to true, the DynamoDB use the get item, query and scan in your code. If you put the parameter as a true, then only the DynamoDB use a strongly consistent read during the operation. Now we will see lab on it. So see, we have logged in here as a pro training. Now we'll go to the services, we'll go to database, we'll click on DynamoDB. Very simple. This is the only way you can create a database. Not database table in DynamoDB. Or you can see through command line. We'll discuss that in a future videos. So see here, through the management console, you click on go to services, DynamoDB. Now create a table, because I have not created. You have to give a that you can give, suppose cells order or partition key. See this partition key, suppose I've given reason ID sorry, and see this, I told primary key only 3 data type will work. So means that while creating the table here, you are going to design like how the record will come, how the record will be queried. So string, binary or number, click on number. Add the sorting, like whenever the partition happen within the partition, how you want to do a sorting to any other column name, you can put that. So the partition will work reason ID and something, or you can say reason name. So leave it as of now. I'm just showing a simple demo. table setting, just leave it as it is the default. We'll discuss detail. Sorry. Now create table. Table is being created. It will take very small time. Yes, sales order. So this is an overview. Stream detail we have not, like DynamoDB stream we have not enabled. Table name, sales order, partition, primary short key we have not created. Point in time recovery will enable it. Encryption we'll see that not applicable. Time to leave, that it is disabled, means record will be within the table forever unless and until we are not going to delete it. From our side, table status is active when the created, like object information from any RDBMS is just an DB capacity. Provision read capacity and the write capacity. See this. This is also available here. So this is the way you can create a simple table. So now we will go in item. So item means there is no record. See this, sales order, region ID, scan and query. Query means it will query the record according to the filter. Index will be used. Scan will be completely scan it, your table. We will discuss this here in matrix. Alarm, matrix means you can monitor this DynamoDB, read-write capacity, latency, all can be monitored. Alarm, capacity, indexes, create an index. So you want to use a partition key, index name, project all attribute, keys only, something like that. See, this is cost. So how to create indexes, we'll see that. Global table, what is the global table? We'll see backup, how you can enable the backup, trigger, access control and tag. We'll have a complete video on that. So come here in overview, go to the item and we can start sorry, we can start search. It's nothing. Then we can click create item. So this reason ID I can put 10. Here I can put then string, then reason name, or I have already created one thing. Just let me check that. Order type, yeah, we can put here order type. So it's web portal, then click and append, again string, then payment method. Then payment method will be credit card, online, and then append, then string. You can put region also, like which region is this. So it can be southwest. Simple. Save it. See this. Region ID, order type, payment, or region southeast. No. That is okay. Payment method, region. What we can do is we can click here. We can go to edit. So we'll give region. Okay. Now save it. This is the reason. Now if you go click here and put a duplicate and we try to save again, it will throw error because the reason ID number is 10. It is already exists. So primary, it also works as a primary key. So we can change it. 20 region we can choose South EAST. Here we can put net banking, I mean how the order happened, and we'll leave it as a web portal. Save it. See, till now we have a region ID, order type, payment, region. Can another item have a more attribute? Yes, it can. Let's go to the action, duplicate it, and okay, put here 30 south north. I mean, this kind of output, and then you can put that some payment wallet, web portal, and we can put again an append string region. You put city. Okay, you can put city Bangalore. Am I right? Let's save it. See this. Do you want another item can have a more column or less column? Okay, we'll do this. We'll put 40. We'll remove this line and we'll save it. Sorry. See this. There's no payment method, only region. This column is filled. We can do this. So this is the way you can have a different kind of values attribute for every item. So this is the way then a table work, the information and how to create a table. This information just I wanted to show you. Take away from the session just a second. So what we have learned till now, DynamoDB has a 3 core component: table, item and attribute. DynamoDB table creation is based on the query pattern of application. AWS will take care of all auto admin tasks of DynamoDB like partition, repair, create tables, table provisioning, split partition. In DynamoDB table, name is universal within the region. That is an important point. So in DynamoDB, if you are creating a table with a name, you can also create another table with the same name with different region. So the DynamoDB name is not similar to S3 bucket name. If someone, if you have seen my previous video on S3 bucket, the name is universal within the AWS. But in DynamoDB, the name is not universal within the AWS. Name is only universal within the region within your account. So region behave as an schema like RDBMS. Like within the region, you cannot create a DynamoDB name, two table with the same name of DynamoDB. That I wanted to explain you. In DynamoDB, the table name is universal within a region. DynamoDB table primary key data type would be either string, binary or number. So if you are planning to create a DynamoDB and if you want to put a layout on the paper, try to choose a column or an attribute where the data type is either string, binary or number. Then only you can create a primary key. So DynamoDB is mostly used for an application where the serverless architecture is required to build. This is the most use case. In DynamoDB, there is no limit of the number of items you can store in the table. What we are going to discuss next? We are going to discuss about data type and data model in DynamoDB, read-write unit and throughput capacity in DynamoDB. We are going to discuss DynamoDB auto scaling and peak traffic property. Thank you. Let's keep learning. If you have any feedback, please send us to feedback@kepro.co.in. Apart from that, if you want to learn any technology of blockchain, cloud, data science, ETL, data lake, DevOps, big data testing and cloud testing, please follow us on YouTube, Facebook, LinkedIn and Twitter. Thank you. Thanks again and let's keep learning.